Welcome everyone. In today's video, we are going to learn about metals and non-metals in a simple and interesting way. Let us begin with metals. Metals are elements that are generally hard, lustrous, malleable, ductile, and good conductors of heat and electricity. Most metals lose electrons and form positive ions called cations. Some common examples of metals are iron, copper, gold, aluminium, and sodium. Metals are extremely useful in our daily lives. Iron is used in construction and machinery. Copper is used in electric wires. Gold is used in jewelry, and aluminium is widely used in utensils and aircrafts. Now, let us understand nonmetals. Nonmetals are generally brittle, non-lustrous, and poor conductors of heat and electricity, except graphite. They usually gain electrons and form negative ions called anions. Examples of nonmetals include carbon, sulfur, phosphorus, oxygen, and nitrogen. Nonmetals are important for life and industry. Oxygen supports respiration, nitrogen is used in fertilizers, and carbon exists in different forms like graphite and diamond. Some elements show properties of both metals and nonmetals. These are called metalloids. Metalloids are semiconductors of electricity and are very useful in electronics. Examples include silicon, germanium, and arsenic. Silicon is widely used in computer chips and solar cells. In the periodic table, metalloids lie between metals and nonmetals. An alloy is a homogeneous mixture of two or more metals, or a metal and a nonmetal. Alloys are made to improve the properties of metals, such as strength, hardness, and resistance to corrosion. Steel, brass, and bronze are common examples of alloys. Steel is made from iron and carbon and is used in buildings and vehicles. Brass is made from copper and zinc, while bronze is made from copper and tin. Malleability is the property of metals by which they can be beaten into thin sheets. Gold and silver are highly malleable metals. This property allows metals to be used in making aluminum foils, utensils, and decorative items. Malleability is one of the important physical properties of metals. Ductility is the property of metals by which they can be drawn into thin wires. Copper and aluminium are commonly used to make electrical wires because they are highly ductile. Gold is also one of the most ductile metals. This property is very important in the electrical industry. Corrosion is the slow destruction of metals due to reaction with air, moisture, or chemicals. Rusting of iron is the most common example of corrosion. When iron reacts with oxygen and water, it forms rust. Corrosion weakens metals and damages structures. It can be prevented by painting, galvanization, oiling, greasing, and alloying. An ionic bond is formed by the transfer of electrons from one atom to another. Metals lose electrons and nonmetals gain electrons. For example, sodium transfers one electron to chlorine, forming sodium chloride. The oppositely charged ions attract each other and form an ionic bond. Let us compare the physical properties of metals and nonmetals. Metals are generally shiny, hard, malleable, ductile, sonorous, and good conductors of heat and electricity. Nonmetals are usually dull, brittle, non-sonorous, and poor conductors. These differences help us identify whether an element is metallic or non-metallic in nature. Students, now, we will see important chemical reactions with oxygen. When metals react with oxygen, they form metal oxides. For example, magnesium burns in oxygen with a bright white flame to form magnesium oxide. Sodium and calcium also react with oxygen. Most metal oxides are basic in nature. Now, we will see reaction with water. Some metals react with water to form metal hydroxides and hydrogen gas. Sodium reacts vigorously with cold water, while magnesium reacts slowly. Metals like calcium also react with water and release hydrogen gas. Highly reactive metals react violently, while less reactive metals react slowly or not at all. The next one is reaction with dilute acids. Metals above hydrogen in the reactivity series react with dilute acids to form salt and hydrogen gas. For example, zinc reacts with sulfuric acid and iron reacts with hydrochloric acid. Copper does not react with dilute hydrochloric acid because it is less reactive than hydrogen. Thermite reaction. The thermite reaction is a highly exothermic reaction. In this reaction, aluminium powder reacts with iron oxide to produce molten iron and heat. This reaction is used in welding railway tracks and heavy machinery parts. A large amount of heat is released during the process. Nonmetals reacting with oxygen. Nonmetals also react with oxygen to form nonmetal oxides. Carbon forms carbon dioxide, sulfur forms sulfur dioxide, and phosphorus forms phosphorus pentoxide. Most nonmetal oxides are acidic in nature. These oxides dissolve in water to form acids.
Formation of ionic compounds. Ionic compounds are formed when metals transfer electrons to nonmetals. These compounds have strong electrostatic forces between ions. Ionic compounds generally have high melting and boiling points and conduct electricity in molten or aqueous form. Common salt is a familiar example.